This man came to his grandparents' house for
thermodynamics is small enough thermodynamic equilibrium is huge. And then there's one more question left, right? Redox. Redox is small. I'll do redox first. And then I'll go to thermodynamics and then I'll go to equilibrium. Okay. Chemistry uses the rates of matter and changes one kind of matter to another. Transformation of one matter to one kind of another occurs through various types of reactions. The important category is redox reactions. A number of phenomena, physical as well as biological, are concerned with redox reactions. Extensive use in pharmaceutical, biological, industrial, metallurgical, and agricultural areas. The importance of this reaction is apparent from the fact that burning different types of fuel for obtaining energy for domestic transport and other commercial purposes, electrochemical processes for highly reactive metals, extraction of non-metals, chemical compounds like soda, giant battery, corrosion of metals, hydrogen economy. Oxidation and reduction reaction. Personally, the term oxidation oxidation. Okay. So oxidation is addition of oxygen to an element or compound. Because of the presence of dioxide in the atmosphere, many elements combine with it. And this is a reason. What the hell did I read right now? First, oxidation was described as the addition of oxygen to element of compound. Correct. This is because the presence of dioxygen in the atmosphere, the presence of O2 atmosphere is a lot, and many elements combine with it, and this is the principal reason why they commonly occur in Earth in the form of peroxides. Okay, fine. It's okay, fine. It doesn't make sense, but makes sense. Okay, based on the limited definition, Mg. Okay, fine. The elements magnesium, sulfur, oxidized. 2Mg plus O2, solid, yes. Reaction, the element magnesium sulfur oxidized on account of addition of oxygen. Similarly, methane is oxidized owing to the addition of oxygen to it. Methane oxidized, isn't it also combustion? Okay, so first it was about only addition of oxygen. Then later on from methane being oxidized, they realized something is up with hydrogen. So they made it to removal of hydrogen as well. And then at the end, when they became more aware, when they became more aware, they find electronegative elements, so oxidation. Mm. 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 So not only removal of hydrogen and oxygen, removal of electropositive elements. Addition of oxygen, removal of hydrogen, or the addition of an electronegative element to an electropositive element in a substance. Reduction is removal of oxygen or removal of an electronegative element from a substance, or addition of hydrogen or electropositive element to a substance. Okay. Oxidation is adding oxygen or oxidation. What does oxidation do? It takes oxygen and it kicks out hydrogen. So because it kicks hydrogen out, it kicks electrons also out. Okay, that is oxidation is the addition of oxygen, removal of hydrogen, and removal of electronegative. Removal of oxygen element. Now what is this one? This is the make me think whether lose is it? Oxidation, you kick out hydrogen, so you kick the electron also out. Okay? So oxidation takes oxygen, kicks out hydrogen, and kicks an electron out. Kicks electrons out. Reduction takes in kicks oxygen out, takes in hydrogen, and takes in electrons. What is redox reaction? Redox reaction is a chemical reaction in which both oxidation and reduction takes place at the same time. So then oxidize. H2S, Cl2HCl. Cl2 has 0 sulfur, I don't know. So when you kick electrons out, that means you become more positive. So, but when you kick electrons out, you become more positive. When you take electrons, you become negative, and that means you are being reduced. So here, Cl is being reduced, and here H. So minus 2 is going to positive 2. That means you are taking more positive people. What does that mean? You are removing more negative people. So here is oxidized. So I think H2S is oxidized, Cl2 is reduced. Correct. 3Fe3O4 plus EL. Here is 0. 9Fe. 4Al2O3. O3 we know is O3 we know is 3 minus 2 times minus 6. 2x minus 6. 0, so 8, 3, 4, 1%. Positive charge for aluminium. Here 4 2s are 4 minus 3. 4 minus 2 minus 8. Here 3x minus 8 is equal to 0. So Fe here is 8 by 3 charge. Charge can be like this over. So then from 8 by 3, from a number it goes to 0. That means you subtract it. When you subtract, that means you're adding electrons. So if you're adding electrons, that means you are being reduced. Or if forget about Fe, look at the oxygen there. Your oxygen from minus 8 is going to minus 6. That means you're adding. Oxygen is variable. So Fe3O4 has been reduced and Al has been oxidized. Yes! To any H2 is here also. H2, you can say plus 1. Here Na goes from 0 to plus 1. That means it's becoming positive. That means it's losing electron. That means it's oxidized. And here minus 2 hydrogen goes to minus 1. That means it is added one more. Minus 1 constant, it is being reduced. wrong with this question? Redox reactions in terms of electron transfer reactions. Two Na plus Cl2 gives us 2NaCl. Okay, we can say an element name, a compound where someone is being oxidized, oxygen added, hydrogen removing, electron removing, add in a more electronegative element. If I added electronegative, that is the same in one more way that removing electropositive. So the reduction would be add in hydrogen, add in electron, removing oxygen, moving electronegative, add in electropositive. Fine, makes sense. Half reactions show the involvement of electrons. So half reactions that involve loss of electrons are oxidized. Oxidation reaction. Half reaction involves gain of electrons are reduction reactions. Reduction agent, oxidizing agent. We learned all of that 10th grade. Here's 2Na plus 2 with 2NaH. 2Na here. Okay, let's split it half. First half we get this 2Na here. Here it becomes with a charge. So 2Na plus 2 electron. 2 electron or 1 electron? Okay, leave that. Then here H is 0. H2 is 0. And here it becomes 2H. 2H minus, that means 2 electrons is taken. So H2 plus 2 electron gives you 2H minus. And when you add this and you cancel the electrons, so that 2Na plus H2 gives 2NaH. 2NaH. Oh wait. Yay, it works. Okay. Competitive electron transfer from action. Is this displacement reaction? Metallic zinc, aqueous solution, copper nitrate. Cuprum, Katrina, card, monkey, oil putting ceramic will be high cubic. Zinc is more reactive. What will happen? Place a strip of nitrogen aqueous solution, copper nitrate, 1 mole. So it becomes a reddish metallic copper blue color solution too. Copper nitrate is blue color. Metal zinc we are putting. Now copper comes on the zinc and blue color is gold. Isn't 2 plus ions among the products can be. Now hydrogen H2 as gas. is Mahabharata they wrote just to tell me about reactivity. Oxidation number when two here it's 0 and 0 both are unknown, and when they become H2O, HO is H is positive 1, so O would be minus 2. Yay, I got it correct. An electron shift. Okay. H20 Cl20 to H is plus 1, Cl becomes minus 1. CH4, H4, here H is coming behind, so it will be minus 4, then C will be plus 4, 4Cl2 will be 0, then here CCl4, Cl is minus, so minus 4 and carbon becomes plus 4, Cl is minus 1 plus 4 for hydrogen, so carbon nothing, hydrogen goes from minus 4 to plus 4. So if you do, that means you're adding more proton, if you remove an electron, that means CH4 is being oxidized, and then Cl is gaining electron, that is you're being reduced. In order to keep track of electron shifts in chemical reactions involving formation of chloride compounds, oxidation number. Oxidation number. The oxidation number tells the oxidation state of an element in a compound according to set of rules formulated on the basis of the electron pair. Oxidation, what is oxidation state? Oxidation number tells the oxidation state of the element in a compound. Based on the rules, that's it. Oxidation number is what? Oxidation state of an element in a compound, that's it. Okay, yeah, now some interesting things to come in. It is not always possible to remember and make up easy in a compound which element more electronegative than the other. Set of rules has been there to find out the oxidation number. If two or more atoms, two or more than two atoms are present in molecule like Na2S2O3 or Cr2O7 minus, the oxidation number okay. free uncombined state. Uncombined state, oxidation number is 0. Uncombined state means they are all alone, that element is all alone, then their oxidation number is 0. And then what do we have? After that we have ions. Ions of only one atom. Ions only of one atom. Their oxidation is equal to charge of that ion. That means for free or ungrouped, uncombined atoms, the oxidation number is 0. For ions of only one atom, their oxidation number is what their charge is. All alkali metals are +1, and all alkaline earth metals are +2. So alkali metals are what? Helena, Q, concentration. So I think alkali metals are hydrogen, lithium, sodium, K, potassium, R, the remaining rubbish, whatever that person is. CS, FR, learn these people's names. Then alkaline earth metal is beryllium, Mg, beryllium, magnesium, calcium, strontium, barium, RA, I don't know what that is. So these people are all always +2. Alkaline earth metals are always +2. Alkali metals are always +1. Aluminium, wherever you go, will be +3. Oxygen में etc. Oxygen. Most compounds is -2. There are 2 kinds of exceptions. That is peroxide and superperoxide. Superoxides. Peroxides and superoxides. Oxygen atoms are directly linked to each other. Peroxide में oxidation number of oxygen is -1 Na2O2, H2O2 peroxide. Superoxides, potassium, KO2, RbO2. There, superoxide में minus half is the what do you call the oxidation number of oxygen. So this is first extension is peroxide, superperoxide. This is case, first case. Second case is when that electronegativity stuff comes. Aha, my finger. Second exception. Oxygen is bonded to fluorine. Difluoride, oxygen difluoride or dioxygen difluoride. Oxygen gets a number +2 and +1 respectively. This will depend on the bonding state of oxygen. It will become a positive again. The second case is compound, that is oxygen with fluorine, and that time OF2, oxygen difluoride, means oxygen number of O is F is -1, we know. So at F it becomes -2. So X plus -2 will give you 0. So X will be +2. And then at dioxygen difluoride, F is -2. So 2X -2 is equal to 0. Plus oxygen X is equal to 1. So oxidation number becomes +1. Okay. So uncombined free people are 0 oxidation number. 4 ions of only a single element, it is their charge. And then oxygen and all usually are -2. But in peroxides they become -1. Superoxides then becomes -half. And in bonds with fluorine they become +2 and +1 depending on whether it's difluoro, dioxygen difluoro or oxygen difluoro. And then next one, hydrogen is always +1, but except hydrogen is always +1. But except when it is in binary compounds. Hydrogen is +1 everywhere. Okay, what is binary? Binary is 2. Hydrogen is +1 everywhere except in binary compounds. That is, there are only 2 elements, NiH, NaH, CaH2. That time its oxidation number becomes -1. So bonded to binary compounds, hydrogen is +1 everywhere, but when it's in binary compounds, it is -1. That is NiH, NaH, CH2. Fluorine is always -1. Doesn't care where it is. Other halogens also are -1. But halogens also have -1. Then they occur as halide ions too. Then they occur as their own ion. But when these halogens combine with oxygen, like in oxo acids, oxone ions, they have positive oxidation number. Okay, fine. Metallic elements have positive oxidation. Non-metallic have positive or negative oxidation. Transition elements are whole D block elements. They have several oxidation. Oxidation state, oxidation number, both are same in people. Alfred Stock. Alfred Stock. Stock notation. Stock. Oh, stock notation. I forgot this person how to do this. How is this? First you write, find the positive part. Stock notation, oxidation number is put in Roman numeral. Roman numeral. See, in stock notation, the oxidation number or the in stock notation, the Roman numeral it's expressing representing the oxidation number is put in parentheses after the symbol of the metal in the molecular formula. So stock notation, it is where Roman numerals are used to represent the oxidation state, and they're put in parentheses. And why are they put in parentheses? I have no damn idea. And they're put in parentheses and they're written right after the symbol of the metal in a molecular formula. Fine. Metal, here's the catch. Okay, it helps to identify whether it is present in oxidized form or reduced form. TL is an element. I thought TL and L are two different people. Oh my god, I'm an idiot. It's not Ti2, it's TL. Thallium 2 oxygen. So TL2 and then oxygen. Oxygen is -2. So this is 1. Okay. Then we have Fe2O, Fe2 bracket 3O3, Cu1I, Cu2O. Oh, you Roman numeral, where is the Roman numeral? Very nice, Roman numeral, right? Okay. Idea of oxidation number. So now from the stock notation we can understand more things. So when there is an increase in oxidation number, it has been oxidized. When there is a decrease in the oxidation number, there is a reduction. The reagent which can increase the oxidation number is the oxidation agent and also known as the oxidants. Reducing reagent which lowers the oxidation number of an element. These are also known as reductants. Redox reactions. Reactions involving change in oxidation number of interacting species. Justify the reaction. 2Cu2O plus Cu2S gives 6Cu plus SO2 is a redox. Identify oxidized people and identify reduced people, who is oxidant and who is reductant. So 2Cu2O plus Us 6Cu plus SO2. So here O is minus 2, C is plus 1. Here S, Cn is 0. Sulfur. Cuprum, right? C2S. So let's say this is plus 2 and this will be minus 2. So then, correct. So plus Cu2 is here when you take cuprum, it is becoming 0. Plus the positive is going backwards. That means it is taking electrons. That means it's being reduced. And when you take this sulfur guy, sulfur is becoming positive and bigger number. That means it's losing electrons. That means it's being oxidized. So Cu2O is being reduced and C2S is being oxidized. CO2 is reduced means you are oxidized, oxidized means you are the reductant. Proof types of redox reactions. I'll finish this chapter now. Oh no, I won't finish this chapter now. After types, what is that? he loses at some other time and go